What's going on, guys? My name is Jacob Bennett with Bulldog Analytics, and today we're going to discuss how to apply a quantitative filter to your report based not on the most granular or line level results, but rather on an aggregate value that's been grouped together by a specific attribute or field within your report. Let's go ahead and look at an example of what that might look like. Alright, today I'm using a very simple example sales data set. As you can see on my screen, I've got a simple matrix displaying the sum of sales by order number. Now, the goal of this exercise is to exclude any sales data for an order number with a sum of sales less than or equal to 0. If I were to go and sort the sum of sales in my matrix, as you can see, we've got one order number, 10107, that has a sum of sales less than 0. And the idea is that we would have this automatically filtered out all of our reporting based on this order number aggregation. Let's go ahead and hone in on this order number by applying a filter. I'm going to go to basic filtering and select 10107. Now, if we were simply to come into our sales filter here and apply a filter saying that this needs to be greater than 0, the issue is evident right away, because as you can see, order number 10107 is still included in our analysis, and in fact it's returning a sum of sales of nearly $10,000. When you break this out, you can see that the filter applied to the sales was actually applied at the line level and not that wrapped up order number total. And when we actually clear out that sum of sales filter, you can see that it excludes the line level, but again, it still includes those numbers that we don't care to see in our final analysis. So I've got three solutions I've figured up here. The first being to create a separate table with the fields that you want to group by in the quantitative field to aggregate. So in this instance, I want order number and I want sales. And essentially what we do is we group it by the order number and just have one summed result in the sales column. From there, we can establish a relationship in the modeling and then use this new table as our filter. The second solution is building a calculated column in the main fact table that we can use as a filter in our report. Lastly, I figured out a way to build a DAX measure that sums up the sales column while automatically filtering out any grouped value at the order number that's greater than 0. That's all I'm going to say now. Let's go ahead and dive into how to perform these operations. Alright, so for the first solution, I said we needed to create a new table. So we can do this in two ways, either through Power Query or through DAX. Let's start out with Power Query. I'm going to click on Home, go to Transform Data. Now, as I mentioned, I want just the order number and the sales column in this new table. So I'm going to make it easy on myself and just create a duplicate of the sales data sample table here. From here, I'm going to select order number and sales, right click, remove other columns, and then with just order number selected, I'm going to go up to the group by option, click group by, and then set my settings here. So it shows that we want to group by order number, and then down here for our aggregation, we're going to change count to sales. Our operation is going to be a sum, and this is going to be performed on the sales column. I'm going to click OK, and then now if you sort the order number by descending, you see that everything is unique. If I click on the column and look at my statistics below, you can see that we have 307 count, 307 distinct, and 307 unique. Before we close and apply, I want to rename my table. I'm just going to call this distinct sales data. From here, I'm going to click Close and Apply. Now that we've got this new table in our data model, we want to come to the modeling view and relate it to our model. It looks like it automatically applied a relationship. We can click on that. Looks like it is from the order number to the order number, which is perfect. Many to one, we're good to go. Now here in our matrix, I'm going to go ahead and leave the view as is, and I'm going to find the new table that we created, bring that sales column in as a filter on the visual, change it to is greater than 0, click apply. Alright, so now with this visual level filter, you can see that our order number 10107 is now properly excluded. We can go ahead and clear out that order number filter just to see that it's still populating other data. See, there you go. To prove that the numbers are correct, we can go into our sales data sample. Because that was a visual level filter, creating a separate card over here should not create any issues there. Alright, as you can see, our unfiltered amount is 9959905. I'll pull in one more card here. And on this card, I'll go ahead and filter it just on our order number 10107. So there we can see that this is the amount of the order number that's being excluded. This is the amount of the total sum of sales, and so this 9.966 million down here is going to be the sum of sales excluding the negative impact that order number 10107 has. So this 9,959,905 excluding the 6,162 is going to result in this 9.966 million. All right, that's that. If you're comfortable building out calculated tables using DAX, you can also use that approach instead of building something out in Power Query. I'm going to quickly run through an example of how to do that. Just a reminder, when you go over to the data view, your distinct sales data has that unique order number list with the sum of sales associated with it down the side. So that's how we're going to approach building out our DAX calculated column. I'm going to go up here, click New Table. I'm going to call this Distinct Sales Data DAX. I'm going to use a formula called Summarize Columns today. This isn't really going to be a tutorial around that necessarily, but it does pretty much the exact process that grouping in Power Query does. So I'm going to type Summarize Columns. It asks for a group by column to start. So as we've discussed, we want to use our order number. I'm going to reference the sales data sample order number and not the distinct sales data order number that we created. And then down below, we need to title our column, and then we need to write our expression. Click Enter. As you can see, our table has been created, and we can go over to the data view and see how it looks. All right, there you go. Looks like an exact replica of our other table. All right, now I'm going to click into the modeling view, and I'm going to make sure that a relationship is established on our new DAX table. This is going to be built on order number. There we go. One to many, order number to order number. Clicking back over in our report view, I'm basically going to just keep the same visuals that we have here, but replace all the logic using our new DAX table. So I'm going to click into our matrix first. Right now we've got the sales filter set using that distinct sales data table. So I'm going to actually exit that out. As you can see, our overall totals jump to 9.959905. I'm going to collapse our order number in question here. I'm going to come over to our new table, pull in that sales value as our filter, apply that with it being greater than 0. And as you can see, we are now back at that 9.966 value that we were hoping to see, where it excludes the order number 10107. One thing I'd like to highlight around calculated tables using DAX, there are a few limitations and things to consider that are fairly pertinent, definitely based on how you're sourcing your data. So number one, if the resulting table exceeds 1 million rows, then oftentimes you'll get an error and it won't work. So if you're working with large data sets, that's definitely something to consider. The second and most important thing is whether you're building your DAX calculated table off of a table that's been sourced using direct query. This will work in theory based on how you see it in desktop view, but once this gets published to the service, your DAX calculated table is no longer going to refresh, even when the underlying direct query table sources are refreshing. This is just a limitation when using direct query storage mode and trying to invoke this setting. And so if you're working off of like a shared data set in analysis services or something like that, and you're in direct query, then unfortunately this is not an approach that you're able to take. All right, let's move on to solution number 2. For this approach, I wanted to create a calculated column using DAX, and there's kind of 2 ways we could do it. Number 1, we could create a formula that returns the grouped totals by order number, and then we could apply a filter that says that we only want to return values that are greater than 0. Or number 2, we could return basically a replica of the sales column, but we just exclude any values that are associated with an order number that has an overall total of less than 0. So what I mean by that, if you look at this matrix, and we'll go ahead and remove the filter I have on here, order number 10107 has 8 lines associated with it. What I want my new calculated column to do is to return this negative $6,192.60 for each line associated with that order number. For order number 10408, I want every single line at the granular level to return $553.95. This way, when I apply my filter, all I need to say is total order sales column is greater than 0. I can put this filter at the entire report level, and boom, we've got the data that we're looking for. Now, before I get into the technicality of how all this can work, I basically just want to write the code, show you the results, and then at that point walk you through how everything works together. So like I mentioned, I want to create this in our main sales data sample table, so I'm going to go ahead and click on that and click new column. I'm going to quickly write this code and then we'll come back and revisit it piece by piece. Before we get into the theory of our calculation and trying to understand it, I just want to note that I'm going to return the total order variable here for now, just so that we can kind of understand what that variable itself means and what it returns. And then later on, once we have a good grasp on that, we're going to switch it over to this sales excluding negative, or how I have it abbreviated here, to return our final result and how we're going to use it in our analysis. All right, now if we go over to our data view, we click on our sales data sample table. And I'm going to remove some of the columns we're not working with in Power Query quickly, just so that we can focus in on the columns that we are concerned with. All right, that cleaned it up pretty good, and as you can see now everything is in view. So let's go ahead and go to order number and sort ascending. All right, so as you guys can see, the first 5 lines are associated with order number 10100, and as you can see over in our new calculated column, they all contain the same amount. Well, this 12,133.25 is a sum of all these sales right here associated with 10100. And that goes for the rest of these order numbers as well. This 10103 is a big one. As you can see, it repeats this 54,702 all the way down, which is just a sum of the sales associated with that order number right here. Now that we have this, it's very easy for us to apply a filter based on whether an order number aggregate sum is negative or not, because as you can see, when we click the drop down, we've only got one. It's going to be that 10107. All right, I'm going to remove this filter and we can zoom in on our code and start walking through the technicality of it all. All right, as you can see in our DAX formula at the top, we've got the first variable titled current order number. We're going to skip that for now and circle back to it here in just a second to help explain something. The second variable is called total order, which is what we are returning, and we're going to walk through that now. Most of you are familiar with the calculate function, but for those of you that don't know, it's a very powerful DAX function, and it helps evaluate a given expression or formula based on a filter context or modified filter context, as we'll talk about here in just a second. All right, so the first argument in our calculate statement is an expression. So here we want our output to be the sum of sales over a specific grouping of values. Well, we've got our sum of sales there. Now we need to move on to our filter context. How do we determine that grouping of values that I'm talking about? We have to step back and remember that we're creating a calculated column, so it's taking into account the row context for whichever row it's calculating a value for. Because of that, we need to quote-unquote modify our filter context, because we need to look beyond just the specific row that we're calculating for. Because remember, we're not just looking at the data on that specific row, we're looking at the data for all similar order numbers across multiple rows. If you look in our filter 1 argument, we've got this all function that wraps the sales data sample table. What this essentially allows us to do is to access all the rows of the sales data sample table, even when we're evaluating at a specific row context. That might be something that's very complex to grasp, but basically because we're creating a calculated column and we're iterating row by row, in order to access values beyond just the row that we're looking at, we need to include this all function here. Now, as you can see, we have a filter 2 argument in our calculate function as well. Sales data sample order number equals current order number. Now at first this might seem like it's redundant, but it's not. It's serving an important purpose here, and I'll do my best to explain that. To start off, we have sales data sample order number. Because this filter follows the all sales data sample filter, it's actually taking into account the modifications we have already made to the filter context. So when we say that we're filtering on the sales data sample order number, this is taking into account the order numbers across the entire table. And it's scanning the order numbers across the entire table, and it's seeing which one equals the current order number. Well, here's our variable. Let's jump back up to the top. Variables are calculations that are determined and stored outside of any sort of modified filter context. So this current order number, being a variable within a calculated column, checks to see what the sales data sample order number is on that specific row, and then stores it away where you can recall it later in your calculation. As an example, for our very first row, the variable current order number equals sales data sample order number would return 10100. So below in our calculate function, when the filter contexts are working together to scan through our entire table despite the row context determined by the calculated column, we are looking for any that are equal to 10100, and then based on our expression, we want to sum those up. See, it's important to understand that the filter contexts are all actually a predicate to the expression in our calculate function. That's a lot of big fancy words, and I know that that's kind of confusing, but basically it's able to recognize all of the similar orders across the whole table and sum those values up to return a single value on your specific row, and then it repeats that process for every single row to create a new column in your table. Alright, now that we've tested our total order logic and ensured that it's returning as expected, we can actually switch the logic while incorporating this total order variable to instead return the line level sales amount and only exclude lines that are associated with a total order that has an overall value less than 0. If you jump down to our variable that I have abbreviated for sales excluding negative values, you can see that there's a simple if statement with an expression determining whether the row context for the total order calculation is greater than 0, and if that returns true, we return the sales dollar sample sales amount for that line. If it's not true, we return 0, therefore excluding it from our overall analysis. To see how this appears in our table, all we need to do is change out the variable that the return statement is referencing here. So I'm going to just change this to sales excluding negative and click enter. Alright, now you can see in our total order sales column that it actually matches 1-to-1 with the sales column over here. For as we set up here, we want that to occur for any total order sales value that's greater than 0. However, we know that one order number, 10107, has a total order sales of less than 0. So let's jump down to 10107 and see how it's returning. Perfect. So as you can see, our sales are still populating over here. Obviously, that's not a measure. We haven't changed anything with that. But our calculated column here is returning 0 exactly as we'd expect it to. And if we filter this down to only 0 values, it's returning exactly as we'd hoped, only showing that order number 10107. Now in our analysis, you can really use this calculated column however you see fit. If you want to go with the first option with the total order variable, and you can exclude anything that has a value less than 0, or instead of using as a filter, you can plug this directly into your analysis and use it in place of the sales column. I tend to lean towards the second option, but whatever works best based on the design of your report will work fine, as the logic is the same for either option. Alright, now on to the final solution. Guys, honestly, I was really excited about creating a single measure that could calculate all of this on the fly without having to create all the space that's used up in a calculated column. Unfortunately, I thought I had it and I kept failing. As you can see in my measure here, I've created a very simple calculate sum measure with a filter applied to a new calculated column that I created. I'm not going to get into all the logic behind this today because I think this part is pretty straightforward, but if you click over to my calculated column, it's essentially using the logic I created in solution number 2, but instead is returning true or false based on if this expression is greater than 0. So basically this is a nice little boolean that I can then reference into my measure. Very straightforward, but at the end of the day it does still take up space with the creation of that true false calculated column. I tried group by, I experimented with several different approaches. If anyone has a good solution that we can create, you know, this whole process into one single measure without having to create the additional file size, creating calculated columns, please send me a message. I would love to present that, but at this time I really couldn't come up with something that was good. Alright guys, that's all I've got for today. I hope you enjoyed the content. I hope it also spoke a little bit to evaluation context and stuff like that. A lot of heavy subjects here kind of built into one topic, but I hope you learned something, and I hope to see you at the next video. Thanks.